Hi everyone, I need you to open up your absolute value notes to page 7. So open up your absolute value notes to page 7. Okay, the title of your notes on page 7 says solve quadratic equations by the quadratic formula. So solve quadratic equations by the quadratic formula. Okay, an overview of this lesson. So you might be wondering, okay, why are we doing this now? We just talked about simplifying square roots. We just talked about imaginary numbers. The quadratic formula is something that you have to use if you are not able to factor. So if you're not able to use any of the factoring methods that we talked about in chapter 9, such as AC grouping, difference of perfect squares, GCF, grouping, if you can't use any of those methods, you have to factor using the quadratic formula. So when you get to graphing parabolas in the next enrichment chapter, if you're not able to factor and find nice x-intercepts, you have to use this formula. So I would say that this formula should be your last resort. Factoring is much faster, as you can see from this formula, just by looking at it right now. So again, I would prefer that you choose factoring first, and then resort to this as another method to factor, which you're finding x-intercepts of a parabola. So what I want you to do first, real big in that box that says the quadratic formula, is I want you to write this down. It's always x equals, because we are still solving for x-intercepts of a parabola. Negative b, which we call as the opposite of b, plus or minus the square root b squared minus 4 times a times c all over 2a. If you type in YouTube the quadratic formula, there's a song that comes up to the theme of Pop Goes the Weasel, and you will have to know this formula for the absolute value enrichment test. So I suggest going there. If I could sing, I would do it for you right now, but there will be people singing this to the tune of Pop Goes the Weasel. So again, if you have time, either pause the video, listen to it now, or afterwards, just type this into YouTube and you'll see a bunch of different songs and dances. This is also something in Algebra 2 that you'll have to memorize. All right, so let's do a couple examples together, okay? Let's start with example A. I want to start off with just a basic example, okay? So letter A in your notes is 2x squared minus 3x minus 5 equals 0. Very first thing I want you to do before you use the quadratic formula is identify what A, B, and C are. The very first thing I want you to do is identify what A, B, and C are. Okay, I'm going to write not the absolute value. I'm going to write the quadratic formula on the left over here. And I suggest you do that too, or just look back at the box at the top. So the opposite of b, plus or minus square root b squared minus 4ac all over 2a. So there, it's up there, and you can also see it on your notes if you did not rewrite it. All right, first step, all we're doing is, I always say, plugging and chugging numbers in. We're just substituting the a, b, and c in for the quadratic formula. So always x equals, please put it in parentheses, okay, so negative 3 squared, keep that negative in parentheses, minus 4 times a, which is 2, times c, which is negative 5, all over, so that whole thing, over 2a, which is 2 times 2. So all we did on that step was plug a, b, and c in. Okay, now let's simplify and combine some things. So x equals 3 plus or minus, I'm just going to rewrite that. I will explain what this plus or minus means in a couple minutes. Okay, negative 3 squared, negative 3 times negative 3 is positive 9. Now you need to take negative 4 times 2 times negative 5. So negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40. So that ends up being a plus 40 there. Be careful when you're multiplying. Watch those negative signs. All over, 2 times 2 is 4. Okay, I'm going to put equals here. If you have room, go ahead and write this next step right next to that. Okay, let's rewrite our 3 plus minus. Let's take our 9 plus 40, add what's inside the radical symbol first. So we have square root of 49 all over 4. Okay, so now we've simplified as much as we can up to this point, but I hope you recognize that square root of 49 is a perfect square. So I'm going to circle that. We can take the square root of that. So our next step should be x equals 3 plus or minus. The square root of 49 is 7, because 7 times 7 is 49, all over 4. Okay, so all we did was take the square root. Now this part of the quadratic formula is when we have to split it up. So this plus minus symbol right here just means one of the problems has a plus in it, the other one has a minus. So I want you to make 2 arrows here. Okay, the first one, I always start with the plus. It's 3 plus 7 all over 4. The other one is 3 minus 7 all over 4. So now this is just basic algebra. These are going to be our 2 x-intercepts. So we need to take 3 plus 7, which is 10, over 4. 3 minus 7, which is negative 4, over 4. And then reduce them as much as you can. 10 over 4 is 5 over 2. And negative 4 divided by 4 is negative 1. Since these are x-intercepts, please write them as an ordered pair. So we have 5 over 2, which is 2.5, and negative 1 comma 0. These are the 2 x-intercepts. So if these were the x-intercepts of our parabola, let me draw our parabola here. Okay, so if this was our graph with our parabola, this x-intercept would be negative 1, 0. And this x-intercept would be positive 5 over 2, which is the same thing as 2.5. So don't forget that when you're factoring or using the quadratic formula, you are solving for the x-intercepts of a parabola. That does not change. Okay, so this was an easy one because your square root was perfect. So we're going to try one that doesn't have a perfect square, so I can explain to you how to do that. Okay, let's jump to letter C. Okay, letter C. Okay, I'm not going to rewrite the formula this time because you have it in your notes. Okay, so letter C, we have x squared plus 6x minus 10 equals 0. So this is a problem that if you try to do AC grouping, you cannot find factors. So we have to use the quadratic formula. Okay, so let's first identify what A, B, and C are. Always identify first what A, B, and C are. Okay, let's take our formula. Let's start plugging the A's, B's, and C's in. So we have x equals negative b, which means the opposite of b, which is negative 6, plus or minus the square root. B squared does not have to be in parentheses this time because it's positive. So b squared minus 4 times a times c all over 2 times a, which is 2 times 1. If you'd like to pause this and try to simplify it on your own, you're more than welcome to make sure you know what you're doing. Okay, next step, let's just simplify some things inside the radical symbol. So negative 6 plus or minus square root. 6 squared is 36. Now negative 4 times 1 times negative 10 is positive 40. All over 2 times 1 is 2. Okay, let's put our equals here. Let's add what's inside the square root. So we have negative 6 plus or minus square root of 76 over 2. Okay, so here's the fun part. If you're good at simplifying radicals, you won't mind this. You now need to look at that 76 we know square root of 76 is not perfect. So you need to find two numbers that multiply to give you 76. One of them should be a perfect square. So I want you to think about what two numbers can we multiply 76 by. One of them has to be a perfect square. Okay, I hope you found that 4 times 19 is 76. Okay, and we know 4 is a perfect square because when you take the square root of it, we get a nice number. Okay, so let's go down here. I'm going to circle square root of 4. Okay, so we need to rewrite this taking the square root of 4. Square root of 4 is 2. Leave the square root of 19 there. Okay, all over 2. Now at this point, all we did was take the square root. Do not separate them yet into two different x-intercepts. Let's actually simplify first. If you see this negative 6 divided by 2, we can divide that. And this 2 divided by 2, so let's actually divide those first, then we'll split them up into two separate problems. So what I mean here is negative 6 divided by 2 is negative 3. Okay, so simplify that. Plus or minus, 2 divided by 2 is 1. So you can put a 1 here and then rewrite the square root of 19. Or you can just put it as negative 3 plus or minus square root of 19. It means the exact same thing. So whether you have the 1 there or not is up to you. Remember, all we did was take negative 6 divided by 2. We got negative 3. This 2 divided by 2, and we got 1. Okay, so now we split them up into our two x-intercepts, okay? Starting with the plus, negative 3 plus square root of 19, and then let's do the other one with the minus, negative 3 minus square root of 19. Now, I do not want you to change this to a decimal, so we're actually done. This is an x-intercept, so write it as an ordered pair. This is an x-intercept. So write it as an ordered pair. When you get to graphing, you may have to change these to decimals, but you will more commonly see these with as simplified radical expressions. So that's your answer, completely simplified, because there aren't any perfect squares that go into 19. Okay, let's take a look, and then I'll have you guys try one on your own. Let's flip over and take a look at one that's a little bit different. Let me just find one. Okay, let's take a look at letter G. Okay, so on that back page, once you flip over, so if you guys were in class with me right now, I would ask you, what's different about letter G than the other problems that we just did? So what's different about G than the other problems? Okay, I hope you're saying that this one is equal to negative 1. Since it's equal to negative 1, you need to move that to the other side, okay? So first thing we would do is take this plus 1, I should say, we need to move that negative to the other side. So your equation, your quadratic function will be 3x squared minus 5x plus 1 equals 0. Okay, at this point, you would go through, let's label our A is 3, B is negative 5, and C is 1. Okay, I want you to go through and do this one with A being 3, B being negative 5, and C being 1. Okay, and when you come to see me for the homework, I will check this one. Okay, so go through, you can pause the video right now. Go ahead and do this one on your own, and when you come to see me, I will check it to make sure you have your simplified answer, and you should have two x-intercepts. Don't forget, one of them will be the positive, one of them will be the negative. Okay, so hopefully you've now replayed your video. Hopefully you have letter G done so you can show it to me. I just want to talk about the first part of letter H with you, then I need to show you one more type of these. So letter H is 4x squared equals 7x plus 2. So this is similar to G, but the difference is there's two terms on one on the other, and this time the larger exponent is on the left. So anytime you have that larger exponent on the left, you want to take these two terms and move them with it. So what we would do here first is subtract 7x from both sides. So we have 4x squared minus 7x equals 2. And then to move the 2 over, subtract it from both sides. So 4x squared minus 7x minus 2 equals 0. If you see that in an Algebra 2 class or on the Keystone, again, please move anything that has the smaller exponent to the other side. Okay, you always want to move it to the side with that largest exponent, which in this case is always going to be 2. Okay, so you don't have to finish that one unless you think you need extra practice. Go ahead. Letter G is the one I want you to make sure you have done on your own. All right, flip over your page to page 9. So flip over that notepad to page 9. We are going to talk about, I think we might just do one here together. Yeah, we're going to talk about one of these that has imaginary numbers, and I actually want to do letter K with you. So here are 3 examples. You knew this was coming, I'm sure, of when you have the quadratic formula with imaginary numbers. So like I said with the imaginary number video, the point of imaginary numbers is there's not an x-intercept. Okay, you're going to have a parabola that's never going to cross that x-axis. It's going to happen. Okay, so here's what's going to happen when you try to solve for the x-intercepts. So I'm going to show you with letter K. All right, so let's go through. You just do your quadratic formula like you always do. We label the A, the B, and the C. Okay, so always start with labeling your A, B, and C so you don't get the negatives and positives mixed up. Let's plug our numbers into the quadratic formula. So x is equal to the opposite of b plus or minus the square root b squared minus 4 times a times c. Keep those in parentheses so we know the negatives are there, all over 2a. Okay, so let's simplify. Negative 2 plus or minus square root 2 squared is 4. Now careful here. Negative 4 times negative 3 is 12. 12 times negative 10 is negative 120. So you have 4 minus 120 all over 2 times negative 3 is negative 6. Okay, equals negative 2 plus or minus square root 4 minus 120 is negative 116 all over negative 6. Okay, so you should notice here, well, we have a negative inside the square root. You know if there's a negative inside a radical symbol, it's going to be an imaginary number. You're not allowed to have a negative inside a square root. So we need to get rid of that. In other words, we need to break down square root of 16 as far as we can. So we have negative 2 plus or minus square root of negative 1. And I want you to think of what 2 numbers can we change 116 to? Something times something is 116, but one of them has to be a perfect square. Okay, I hope you thought, if not, pause the video. 4 times 29 is 116. Okay, 4 is the perfect square. So our next step here is to simplify. This is a perfect square, and we can also take the square root of negative 1. Okay? Let me make this a little bit bigger. All right, so we have negative 2 plus or minus. The square root of negative 1 is I. Okay? So put your I here. Square root of 4 is 2. Leave the square root of 29 in there, all over negative 6. Okay, so if we look at this one, we could simplify this, okay, a little bit. And let's simplify this with the fractions, okay? If you didn't simplify something like this, I'd be okay with it. But if we look at this -2 over -6, we can reduce that. And if we also look at the 2i over -6, we can reduce that. So let's simplify it and then we'll split it up. Okay. -2 over -6 is positive 1/3. So we have positive 1/3 for the first part. Okay, now the 2i over -6, okay, that's going to be a minus. So we still have our plus minus. And then this part's kind of weird with simplifying. Okay, so plus minus a negative 1i or just I over 3. Since that's negative, I know it's going to be weird, but just keep that negative there. We'll simplify it once we split it up. The square root of 29 goes next to that negative I over 3. Okay, so now we have our fractions. It's simplified. We're ready to split it up into our two imaginary x-intercepts. So I'm going to draw the arrows. Okay, one of them is with the plus, excuse me. So we have 1/3 plus negative I over 3 square root of 29, comma 0, because it's an x-intercept. If you would prefer, instead of the plus minus, to just make this right here a minus, you can do that. That's completely up to you. The second one is going to be 1/3 minus negative I over 3 square root of 29, comma 0. Now, if you have minus a negative, change that to plus. Two negatives back to back is a positive. So that one should be the one that has a plus. The other one is plus a negative, which is the same thing as subtracting. So there are your two imaginary x-intercepts. One of them has the minus, one of them has the plus. Okay, if you have any questions on that, please see me when you come to get your assignment. I would like you to do, besides finishing letter G, I want you to do letter L. This one will have imaginary x-intercepts. Okay, simplify it completely, and then when you come see me to get your assignment, I want to see letter G completed, please, as well as letter L. Okay, and do not wait until right before the test to get help or to show me assignments. Okay, so that ends solving equations using the quadratic formula. Again, remember, you use that whenever you are not able to factor.